Curious, observant, in the cool mountain streams of Southeast Asia lives a highly elusive predator. Xenodermus javanicus is immediately recognizable by the three distinct rows of raised, keeled scales, a rough, ridged texture running down its back. It is a striking, highly sought-after animal in the exotic pet trade. Yet for decades, keeping one alive in captivity was considered entirely impossible. Experienced keepers would acquire a healthy specimen and place it into a state-of-the-art terrarium. Within weeks, the animal would inevitably perish. The dragon snake's failure to thrive revealed that the established rules of the reptile trade were insufficient for specialized wildlife. Early breeders noticed the animals were incredibly skittish. They hypothesized that the snakes were dying of neurological shock, brought on by the stress of human observation. This anxiety was a symptom, not the cause. The snakes were reacting to a catastrophic failure of their immediate environment. To stabilize the species, keepers had to identify exactly which biological parameters were being lost in the translation from the wild jungle to a glass box. Reversing the high mortality rate meant treating standard reptile care as a list of mistakes rather than a solution. The most significant error was found in the temperature gradient. Standard heating setups were accidentally baking the dragon snakes alive. While common pet snakes need basking temperatures over 90 degrees, that heat is lethal for a dragon snake, suffering at just 85. To function properly, this species requires a remarkable cool gradient, dropping to 75 degrees, with a maximum warm side capped at 85. Because they are strictly nocturnal, they lack the heat tolerance of typical basking reptiles. Maintaining this cool environment is a biological requirement. The universal assumption that more heat leads to better health is the opposite of what this creature requires to survive. The next error involved moisture. Providing a standard dry hide box and relying on baseline room humidity left the snakes chronically dehydrated. They require a hyper-specific wet microclimate. Keepers must maintain constant humidity between 70 and 80%, using deep, moist soil and sphagnum moss to allow for natural burrowing. Beyond the environment, a persistent failure in early husbandry was the attempt to use a standard rodent-based diet. This diagram illustrates their specialized predatory nature. Standard snake prey like mice and rats are ignored, replaced exclusively by an aquatic diet of small fish, tadpoles, and earthworms. This specific dietary profile mirrors the prey availability in those wet, mountainous streams where the species evolved. Keepers were failing because they forced a specialized, cool water hunter to survive in the environment of a desert scavenger. Today, successful care for a thriving dragon snake looks radically different from those early, failed enclosures. A correct setup is a 20-gallon or larger bioactive swamp environment, a heavily planted, self-sustaining enclosure. It features deep, wet substrate, large, shallow soaking dishes, and abundant cork bark hides that match a Southeast Asian microclimate. Handling must be strictly limited to brief, once-a-week sessions. However, providing a secure, heavily covered environment prevents the stress responses that were once thought to be fatal. When these ecological parameters are respected, a delicate specimen transforms into a robust, living display animal. The history of the dragon snake offers a lesson for advanced exotic pet husbandry. We cannot force highly specialized wildlife to adapt to the conveniences of standard pet care. We must adapt our practices to match their evolutionary biology. If you are an experienced enthusiast ready to attempt keeping the species, you can find our comprehensive care guide over on Crullo. The platform provides the gear lists, feeding charts for juveniles and adults, and the specific temperature guidelines needed to maintain the specific environment. Successful reptile keeping is not about convenience. It is the science of recreating a piece of a species' native world.